Now, as we go into topic 2 of our course, we're going to take a look at Venn diagrams and subsets. So there are a number of objectives that we'll look over. Use a Venn diagram to depict set relationships. Determine the complement of a set within a universal set. Determine whether one set is a subset of another. Understand the distinction between a subset and a proper subset, and determine the number of subsets in a given set. Now, there is a little short video that is produced by the authors of the textbook that I should show you where that is. So if you go to the main menu and then chapter content and then pick chapter 2, this comes up and we are in section 2.2, and then over here there is the section. This lasts about 8 minutes. Ours would be a little more thorough discussion and representation, but this is very good to give you sort of a real condensed view of what's in the section. And I look at them too. So again, a couple of key terms that we're looking to define, and in any notes you would take, you'd want to be sure that these are addressed somewhere. But let's take a look now at the Venn diagram itself. We'll see it perhaps a little better down here, but we'll get to that very shortly. Take a moment to read this over to yourselves. Pause the tape. So then, in summary of this, we see that we do have what is called the universe of discourse, which is the area that's under discussion or the thing you're looking at. And they're giving you an example of a vocational school where it may be the students, the board of trustees, the oversee board, the state regulatory agencies, or perhaps all of these would be your universe of discourse. You focus on what you want to have your diagram represent. So the universe of discourse is what we call the universal set. And we use the letter capital U to designate this. Now, this was developed by a John Venn. His dates are here, and I always knew the word Venn, but wasn't particularly familiar with. I knew someone had named it, and here it is. Now, the universal set is shown by a rectangle, while the subsets, or the items inside, are either ovals or other shapes. So let's take a look at this in more detail. So as we start to build vocabulary, the rectangle shape is the universe. A subset of the universe is, let's say, set A, and everything not included in A as part of the universe is considered the complement of the set, and it's written as this, which is referred to as A prime. So what is A prime? A prime is the complement. That is, all of the things in the universe that are not in set A. It's sort of what's opposite to it, or what is outside of it. So let's look at the complement of a set. So for any set A, within a universal set U, The complement of A, written A prime, is the set of elements of U, that is the universe, that are not elements of set A. And in set builder notation, this is how it would be written. So the complement of A, or A prime, is equal to X, such that X is a subset of U, the universe, and X would not be members of set A. And again, you may have to pause, and I would include that in your notes. Now, in doing example A, where we are asked to find the complements, we are given the universal set here, and we are given set M. But we want to find, for letter A here, the complement of M, or M prime. And by definition, it is what is not included in set M of the other things of the universe. So A is there, B is there, C is not there. So we put C, D is not there, E is there, F is there, and then we have G and H. And that is our complement. And that's how we got it. We looked at what's the universe, what was set M, and then in the universe, what is not in set M would be its complement, described as M prime. Now, as we go on to part B, we're looking for the complement of N, which is N prime. So, as we look at the universal set, N starts with B, so A is part of the complement of N. B is there. C is not there. D is there. E is there. F is not there. And then G and F. So again, the set is N. Which parts of N are to be found outside of it in the universe? That would be the complement of N, or N prime, and it's A, C, F. Now, by going through your text, you pick up some other things that may not be given in a normal lecture. For instance, the universal set. What is the complement of the universal set? Well, it would be written U prime. And since the universal set includes everything, there isn't anything left in the U prime, that is the complement of U. So since there's nothing there, it's an empty set. Now, what would be the complement of the empty set? Well, that implies it would be the universe. And that's what they're indicating here. All right, let's go on. Now, we're looking at what is called the subset of a set. So let's say our universal set is this. while A with these members would be considered a subset of this, because all of these members are within the universe. Now we write that, and again, when you're writing, it's kind of hard to exactly make that symbol, but it's sort of like a capital C with an underline, and that is read that A is a subset of U. Now, if A were not a subset of U, you would just put a slash through this. Again, giving you some of the technology needed to write the sets properly. So here is the rule, and we have just gone over that. So let's look at an example. Now, for something like this, this is where you get a chance to look at what's here. And don't look at the answer yet, because the answers are down here below. You want to determine whether you're going to put the subset symbol or not a subset symbol in this to determine if these, to make the statements true. So let's pause. Well, you wonder why something is true. Again, every element in this set is found there, so it is a subset. Here the 1 is not found there, so this is not a subset. Here the elements are the same in both, or in a different order, so in a sense is a subset of that. Keep in mind that previously we also said that these sets were equal. And the cardinality of this, remember, was 4. And you have to keep thinking of what we've already covered and tie it into things and perhaps use it as a review from time to time. And here they're giving us the support of what we just said, that B is a subset of B, and for any set, that a set is a subset of any set. And that's what they're showing here. Now, how about when we think of a new term here, a proper subset? Let's take a look at this definition. So as we look at this, we have set A and set B. Well, A is a subset of B, but B is not a subset of A. Now, since A has fewer elements than B, we give that a special designation, and we call that a proper subset. Now remember, in an earlier example we said that is B a subset of B? We said yes, because they were identical. But they weren't a proper subset. In order to be a proper subset, it has to have less elements than the other set. So a little distinction, a little subtlety, that again is part of your vocabulary. And notice we're changing the symbol for the subset here. We don't have the line underneath it. This is a subset by itself, a proper subset with at least one less element than the other. So a way to write this as a rule, set A is a proper subset of B. Now, A is a subset of B, but since A does not equal B, that is, there are fewer elements in A, it is written A is a proper subset of B. And now we'll do some examples. And once again, you're looking at the examples, and don't look at the solutions yet. Think about it, but this is your backup. So as we look at this, 5, 6, 7, 5, 6, 7, 8. So we know that this is a subset. And since this has one less member, it is also a proper subset. Now, since these are the same, we know it's a subset. But since the items are identical, it is not a proper subset. Now, reading this little part, it says that an empty set is a subset of any set. So this, again, by definition here, they're saying that an empty set is a subset of any set, in this case B. This is true because it is not possible to find any element of an empty set that is not also in B. There are no elements in an empty set. The empty set is a proper subset of every set except itself. So just remember that an empty set is a subset of any set. In this case, they're using B. And an empty set is also a proper subset of every set except itself. Again, you're going to have to study this and memorize it. Okay, and that's what they're saying here in both of these cases. So every set except an empty set has at least two subsets: an empty set and the set itself. Okay, now we're going to go into what is called listing all subsets of a set. Now I'll do the first one here. So we have the elements 7 and 8. So one of the subsets of this would be an empty set. We say that's a subset of any. Another would be the subset 7. Another would be the subset 8. And then itself, 7, 8, would be another subset. That is how we can combine them to get our various possibilities. So how many subsets do we have when they are two elements in a set? Well, there's 1, 2, 3, 4. So we say it has 4 subsets. Now if we did the B, and I'm not going to do it because it's done here, so let's just follow it. Again, there's the empty set, there's the A, there's the B, there's the C. then we could have an AB combination, an AC combination, and a BC combination. And then, of course, we have the set itself. So let's count them. 1, 2, 3, 4, 5, 6, 7, 8. For this one, there are 8. And this one we said there are 4. So if we had in our next one 4 elements, would we be able to find a pattern? Now, the author, in their video, they go through this and they show you the pattern, and they're summarizing it, giving you a summary of it here. So if we had 1, there would be 2 possibilities, an empty set and the 1. Here we said if there are 2, we have 4. And if we have 3, there are 8. And so on and so on, if you follow this pattern. Well, what is the pattern that's being developed here? Well, it's powers of 2. So if we have 2 to the first power, 2 to the second power, 2 to the third power, 2 to the fourth power, 2 to the fifth power, and what are these numbers here? So if we have one item in the set, we're going to get 2. If we have 2 items in the set, 2 to the second is 4. If we have 3 items in the set, 2 to the third is 8. And how would we predict if we had 4 items in the set? This would be 16. If we had 5 items in the set, this would be 32. 2 to the fifth is 32. Now, what general formula might we produce from this sequence? And the book comes up with, and I've seen it before, 2 to the nth power. Now, 2 to the nth power would be where n is the number of elements in the set, the number of subsets. And here we're showing the beginning of how we derive this formula. Now, an aside to this is, suppose you were looking for a perfect subset number. Well, it would be -1. Remember, they couldn't be the same number. It has to be 1 less. So this 2 to the nth is for general, and for perfect subset would be -1. So for counting subsets, they're giving you this tree diagram, which is another method of doing it. And then they're developing a similar chart to what we had suggested earlier. And we did that. Okay, good. So as you look at your textbook, they give you a lot more material. And there are the formulas we've come up with. So let's pause there for a moment. And again, if you have 1 element, 2 elements, here, 3 elements, 4, 5, you get the expansion of 2 to some power, which is what we said was the number of subsets. And I think I used the word perfect. It should be proper. The number of proper subsets is this. So include this in your notes. This is sort of the shorthand way. where n is the number of elements in the set. And to get the proper subset, we must subtract 1 from that value. Well, if it was 2 to the 30th, you'd see 1 wouldn't make a lot of difference, but that's the formula. All right, let's go on. Now, we didn't look at Chapter 1. It's not in our curriculum. But they do mention reasoning, inductive reasoning, and discovering principles, which we'll be using a lot later in the book, and arriving at conjecture. And again, conjectures may or may not be true, but we have proven through what we've just done on the previous pages that the formulas that we have are good. So for the general number of sets, we're going to use this formula. And for the proper number of sets, we'd use this formula. So with that in mind, again, don't look at the answers. See if you can figure these out for letter A and letter B. So hopefully you looked at the number of elements in this set, which were 5, the number of elements in this set, which is 8. And they want us to find the number of subsets and the number of proper subsets in each. So the basic formula would be 2 to the 5th, and then later 2 to the 5th minus 1. And this one would be 2 to the 8th, and then 2 to the 8th minus 1. So 2 to the 5th is 32. This one would be 32, and this would be 31. And for this one, 2 to the 8th is 256. So this is 255, the proper subset. All right, that finishes the general discussion of the chapter, that section. We're now going to do a little exercise here where we match sets or things in column 1 with column 2 and see what we end up with. Now you'll have your practice in your study plan and your quiz me's as you achieve your mastery points.